How are you, my dear students? You know we are also studying a new topics, maybe very interesting topics, and also physics-based topics. Here's the we also explain about the earth and the gravitation. In the previous class, we also learned about the Newton's law and the gravitation, gravity, and the acceleration due to gravity. And we also know about the Newton's law of gravitation and gravitational force. Yes, we also know equal the F equal to G into M1 M2 divided by d square. My dear students, today I have just also select another important topics. Here's the important topics is the lesson 4 and also the lesson 5. Here's the lesson 4. We also know about the mass and weight. Here's the mass and weight. They have the relation between the mass and weight. Please everyone open the books and page number 73. Here's the 73. Please everyone see again. In our day-to-day use the language, we often make no distinction between mass and the weight. But in physics, the two words mean different initiates. In fact, when we say that the weight of a bag of rice is 50 kg, we actually refer to their masses. In this respect, the use of the word weight of an object is scientifically wrong. But what is the difference between mass and weight? Here's my dear students, I just also write the mass. Mass and weight. Basically mass of an object refers to the amount of material present in an object. Again, I also repeat, here's the mass, basically mass of an object. Yes, it's also the another name is the object refers to the amount of material present in an object. A heavy mass is expressed in units of tons. The another word, basically a heavy mass is expressed in units of tons, and 1 ton is the 1000 kg. Now, the mass. All objects are made of materials. Mass of an object, again I also repeat, refer to the amount of material present in an object. This property of the material does not depend on location, shape or state of motion. According to Newtonian physics, the mass of the object depends on the number and kind of atoms and the bonds by which the object is formed. The international unit of mass is kg. A heavy mass is expressed in units of tons. 1 ton is 1000 kg. Small masses are expressed in units of gram. Thus, the mass of your pencil is the 5 gram. 1000 gram make 1 kilogram. More appropriate meaning of mass comes from Newton's law equal to F equal to ma. Yes, the another law is the, I also write this, the 5 equal to m into a. Thus, the mass of an object is the ratio of F and acceleration. If the mass is greater, it resists the increase of velocity more. For the same applied force, mass is thus related to inertia of motion. Now, the weight. We know that if a body is thrown upward, it comes back on the earth to the earth. This is due to the weight of the body which push the object towards the earth. We can say the force of gravity causes the downwards pull. The force by which the earth attracts an object to its center is called the weight. Again, I also repeat, my dear students, the force, basically F, is another name is the force by which the earth attracts an object to its center is called the weight. If the mass of an object is m and the acceleration due to the gravity at place is g, another the mass is the object is the m and the gravitation force is the another name is the g, and the final we also know that the gravity at place is g. The weight of an object is w equal to m into g. The unit of weight is Newton. Yes. The unit of, please everyone underline this word. The unit of weight is Newton. The weight of an object is mass 10 kilogram is W equal to 10 into, again I also write this, W equal to 10 into 9 to the power 8 Newton. Here's also the 98 Newton. Generally, we can determine the weight of an object by using a spring balance. My dear students, again we also done another lesson. Here's the another lesson we want to know about the relation between mass and weight. We know that the amount of material in an object is its mass. It is a constant parameter which does not change due to change of its location to any height above the earth. If an astronaut has a mass is 75 kg, it will remain unchanged when he is the surface of the earth or on the surface of the moon or in an orbit of the moon or earth. The amount of material by which an astronaut is built does not change due to change of position, and that is why its mass remains unchanged. Since the mass of an object is constant, its height changes due to change to the, my dear student, the change to the value of small g. As one goes more and more above the surface of the earth, the weight of an object becomes less and less. The reason for which the value of the acceleration due to the gravity changes are also the causes of change is weight of an object. The weight of an object is not fundamental parameter. For example, an object may have weight at any place, one place, and may not have any weight at another place. At the center of the earth, the value of the acceleration due to the gravity is 0, and therefore the weight of an object there must also be 0. At a distant space where there is no gravitational force, the weight of an object must be 0. The value of acceleration due to gravitational force at the surface of the moon is 1/6 compared to that surface of the earth. You can find out that weight of 1 kilogram of material at the surface of the moon is about only 1.63 Newton. The weight of an object at a location depends on its distance from the center of the earth. If the distance is increased, the force of gravity due to earth at that point decreases. As a result, the weight of an object there decreases. At the surface of the earth, the weight of mass 1 kilogram is 9.8 Newton. But as a distant point from the earth, the weight decreases with the increase of distance. The weight of an object varies slightly also at different positions on the surface of the earth. One reason for this is that the earth is not a perfect sphere and the acceleration due to the gravity is not same on the points of the earth's surface. However, this variation is so small that it can be detected only by using a very sensitive weighting machine. We neglect that this variation in most of our calculations. An object will weight maximum at the two poles. At these places, 1 kilogram will weight 9.83 Newton. At the equator, please everyone, again I also repeat, the places 1 kilogram will weight is 9.83 kilonewton. At the equator, the weight will be least with a value of 9.78 Newton. At the equational point, the weight is 9.79 Newton. Again, I also explain here's the 9.83 Newton, 9.78 Newton, and the 9.79 Newton. The weight is the body increases in proportion to its mass. Therefore, the instruments which are used to determine weight can also be used to measure the mass of the object. Often, spring balance is celebrated in units of kilogram. Balances and weighting instruments are celebrated in such a way that we sometimes use the kg unit for measuring both mass and weight. It is, of course, a wrong practice. Weight is a form of force, and for scientific calculation it should be expressed in units of Newton. When we buy a packet of rice or milk on which 1 kg is marked, we understand that each of these packets has 1 kilogram mass. But their weight are not 1 kg. On the surface of the earth, they will weigh 9.8 Newton. These packets will weigh different from planets to planets or on the moon, although their masses will remain unchanged. My dear students, today I also explain about the mass and weight. Here you also know the F equal to ma or F equal to mg. Here also the F is meaning the force, m is equal to the object, and g is the gravitational. Here's the gravitation. We also know the 9.83 Newton and also the 9.78 Newton and the 9.79 Newton. And we also explain about the relation between mass and weight. Again, I also repeat, my dear students, we also explain about the basically chapter 7. Yes, the chapter 7, the headline is the earth and the gravitation. Basically, it's also the mathematical term. Here's the mathematical term. We also know F equal to G into M1 into M2 divided by D square. And we also know about the F equal to MA. Yes, the M. Again, I also repeat, my dear students, if we have only the two mathematical terms, here's also first is the F equal to G into M1 into M2 divided by D square. And the another mathematical term is also the F equal to MA or F equal to Mg. And we also know about the relation between mass and weight. In the next topics, we also select the next class, the acceleration due to gravity and the weight of an object are different at different places on the earth. I hope it's also the another very important topics. My dear students, I think today that's enough. Goodbye.